All right, welcome to Mr. Max Review, day 2 for Algebra 1. I'm here with 5 million kids that have waited to the absolute last minute to learn this stuff. What? I can't hear you through your braces. What? The first what? Oh, the first like. Okay, I don't know who that is. I'm not reading it. Okay, I'll figure it out later. But Chloe apparently said she liked my channel because she falls asleep every night to this video. So, Chloe, if you are sleeping right now, okay, hello. You're dreaming of a dog. This dog is dead. It was run over by Reese because Reese kills animals. Ask Eli Perez. All right, anyway, so we're going to do quiz 5 first with these thousands of delinquents that waited to the last minute to learn any of this stuff. I normally teach this over 16 weeks really slowly. Today the challenge is, can we teach 16 weeks of material and have it be understood in less than 3 hours? How hard could it be? How hard could it be? Okay, I'm sure it's fine. We definitely don't need 16 weeks to learn this. We just do that for fun. This is really all you need. Okay, so starting with chapter 5. Are we going to do all the basics, or you want to go line by line? All right, let's do them. X in terms of Y. What does that mean? Yeah, Jackson. Yes, X will equal a bunch of junk with Y in it. And notice it will not have X in it. Okay, you can't define X with X. That's a bad definition. That's like defining a dog as something that's dead and is a dog. Okay, that's not how you do it. You can't define it with itself. Girl, yes. Why wouldn't it be? Do you want these or not? Okay, so then you should just watch instead of writing stuff down. You know I'm going to scan all this and send it to you anyway, right? Good. So you should just try to think as we do this instead of writing stuff down. The best way to take notes is to think and write down stuff that you know but you don't want to forget. If you don't actually understand it, never write it down. All right, so let's get X on its own. Well, that means we have to get rid of everything that's not X on one side. So how am I going to get rid of negative 4y? Add 4y to both sides. That'll make this 0, and now I have 7 plus 4y on this side. Now, this is what 3x is in terms of y, but I want regular x. How do I get rid of that 3, Jackson? Divide everything by 3. You cannot subtract to get rid of this thing. It doesn't work. I'm dividing because this is 3 times x, and if you divide it by 3, what is 3 divided by 3? 1, and that's 1x, isn't it? That's what I wanted. So to do that, I have to divide everything by 3. Because these aren't divisible by 3, even if some of them were, like, it has to be all of them. Since they're not all divisible by 3, I'm just going to write it like this. Ta-da, x is on its own in terms of y. If that was a 6 and that was a 9, then we would divide them out maybe. That would make things easy. But because they're not both divisible by 3, just leave it like this. How do we feel? Okay. All right. Tell me if it's out of screen anytime. Y in terms of x. So if we have the same equation, but now we want y on its own. Can somebody tell me the 2 things we're going to have to do? Give me one thing we're going to have to do, Jackson. That's not a bad idea, because that'll at least make y positive. However, it's not 100% necessary. Give me one thing that's definitely necessary. Yeah, how will we do it? Give me one thing we have to do. Go ahead, Jackson. Yeah, if you minus 3x, that'll get y more on its own. And then we divide by negative 4, right? So you could make y positive if you want to, but we're going to divide by negative 4 anyway, so who cares? It's up to you. It's up to you. So I'm going to subtract 3x first. I usually do my adding and subtracting first just to make things a little bit easier to work with. And then I'll divide last, but you don't have to. You could have divided first. You just have to do it to everything, right? So if we take this whole thing and divide by negative 4, we get this. Fractions are division for lazy people. How do we feel about this? Good. Do you understand this one? Subtract 3x, divide by negative 4. Better? For real? Okay. Now for this one, we want to find numbers that work for P and Q. I'm going to write Q first because Q's first over here. You guys always flop these on accident, and it's funny to me because it says PQ here, which is alphabetical, and this isn't alphabetical. All right, Jackson, give me one pair of numbers that work. 1 and 1's a good start. Here's why 1 and 1 works. You have to understand why this works. A lot of people think it's because there's a 1 here or something. No, just focus. If Q is 1, we get this, right? What is 3 times 1? If P is 1, we get this. What is 2 times 1? So it's 2. Is this true? Yes. So that's why 1 and 1 works. Now, you can give me other numbers, right? There are 3 pairs we're looking for. You can give me other numbers, but they don't have to be nice numbers. So does anybody know a nice pair of numbers? Okay, that's fine. Okay, that's totally fine. So 3 and 4 would get us 9 minus 8, so that works. You guys seeing that? 9 minus 8? Now, cool fun fact of the day. This amount of change and this amount of change got us nice numbers. So if we do that amount of change again, we're going to get another pair of nice numbers. So now that I know this, I can apply that and get 7 and 5 for my other one. That's 15 minus 14. Thank you. So do you see if I do this again, I'm going to get 15 minus 14, which is 1? So that works. Now, fun fact, this is called delta P, the change in the P value. This is called delta Q. It turns out delta P will always be this value right here. And delta Q, I know it's kind of weird because it's like the opposite, is always going to be this value right here, except one of the signs have to change. Now, why is this? We talked about it right before break. We proved it. We had delta X and all kinds of stuff, and we had to distribute, and we had to make things go away. We're going to hit it again with Chapter 8 soon, so if you want to use it, go ahead. But if you don't understand it, what I like to do is find 2 that are nice, and then I just steal it, kind of like we did here, right? And then you can be sure of it. But that's the idea. Remember, no notes on the final, so you can't just like look at this. So there. Did you hear that? No notes on the final? Good. It says 3. I don't think so. They better not. No, he's taking it tomorrow too. They take it over multiple days because it makes sense that we should challenge them less because they're, yeah, I know. Because they're going to like the zoo or something dumb. Should have done the dodgeball tournament, losers. All right. Because people are dumb, yeah. I don't remember and I don't care. All right, so this is a waste of time and stupid. So let's get back to this. We need to find numbers that work. Now here's the problem. Guessing and checking like on the last one isn't going to be fun because you might find numbers that work for the top, but you probably won't also find numbers that work for the bottom at the same time, right? So we need to have a method, yes. No. So elimination, substitution are our options. I mean, she used to when we were first dating because she didn't really know who I was, and so she'd watch the videos and she'd be like, oh, this is great. Yeah, she's a big fan. She's a children's librarian, so we're both kind of like kindred spirits, right? No, she works at a library. All right, so, yeah, Sterling. She's the head children's librarian, and it's local enough. All right, fam. Elimination or substitution? So if I do elimination, that's adding and subtracting and making stuff go away. If I add or subtract, will anything go away? No, not right now. So let's do sub. Let's get a variable on its own. How about we get this bottom one on its own and get x on its own? I'm going to see if you guys can follow my logic. X is going to equal negative 4 plus 5y all over 2. Are you guys seeing that idea? Yeah. Add 5y, divide by 2. Add 5y, divide by 2 to get x on its own. What were you guys doing in 8th grade that you were good at? That makes me wonder. All right, no. Hey. Rule number 6, please. Or number 5. All right, okay. So anyway, this right here is what x is in terms of y. Why is that useful? Because we can substitute it into here. Do you see how this is 3 times x? X is the same as this. They're interchangeable. Why is that a good move? Why do we want to replace x with this abomination? Because when we replace it, everything will be y's, and we can solve for y. That's not a big deal. Fractions. All right, fam. Okay, stop. So this is all one term. So you can either divide both of these by 2. Can we divide both of them by 2? No, not BOFA. This says divide BOFA. So you can't divide 5 by 2. I mean, you could. It'd be like 2.5 or something. But why would you want to do that, right? This can divide by 2, but it can't, right? So what I mean by that is you could divide these, but is 3 divisible by 2? No, so you probably don't want to do that. So how are we going to get rid of this divide by 2 then? Multiply everything by 2. You can do that in an equation. This is an equation. So I'm going to times every term by 2. This is all one term. This is all one term. This is all one term. Right? Just like we had 3 terms earlier. We have 3 terms now. And so the reason we did this is because 2's divide out and we get 1. And 1 times 3 is just 3. This is chapter 5, which is the hardest chapter according to a lot of people. But it's really not that hard. What's really funny is that you guys did this in middle school. That's what's really funny about this. Yep. I know you did say you didn't, but I know for a fact you did. Steely Alba literally came over last year and asked me for help doing this stuff. Ding, 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 ding. So you did it. I win. All right. So, fam, do you see how I doubled everything, which gets rid of this, right? It was half of it. So if I doubled this term right here, right? This whole term right there. You do not double the 3 and double to get rid of this. Because this is one term, right? Would you double the x and the 3? No, you just double the 3, right? Here, we doubled the underneath. So we're not going to hit it again, right? This is all one idea right here. 3 times something, right? Just like 3 times x is all one idea. So you hit this once. We already hit it here, so why would we hit it there, right? We hit this once. It's a separate term. We hit this once. It's a separate term. So now, can we divide this term, and this term by 3? We could, but it would be fractions, right? So, no. Instead, what are we going to do? Distribute. We get negative 12 plus 15y minus 4y equals 10. And after we get our y's together, we're going to actually be able to solve for y. So this will come out to negative 12 plus 11y's equals 10. Now, you could add 12 to both sides if you want to. That's fine. Then we get this. So what does y have to be then? 2. Now, I oftentimes don't add 12 to both sides. I just do this and been like, what do you add to negative 12 to get 10? 22. So what does that mean? This part has to be 22. Same dumb crap, right? Y is 2. Now that we found y, we can quickly find x. You can plug it in here, but wouldn't you rather plug it in here? If we know y is 2, Ember, what is this going to be? Good job, Ember. What's negative 4 plus 10, Ember? What's negative 4 plus 10? 6 divided by 2? X is 3. Those are the winning numbers. X is 3, y is 2. That is the only pair of numbers that'll work for BOFA. Sorry. That's why guessing and checking would be a really bad idea. You would, because they're not so bad. Depends on what you start with, yes. Yeah. But like sometimes it's fractions, sometimes it's like doesn't exist at all. Sometimes it's infinite solutions, right? So yeah, it's just not a good strategy if it only works part of the time. You could, except this one says use substitution. For the last one, yeah, you can use substitute or elimination. You just have to make a match first and then add them up or subtract them, yeah. What? Okay, so you got a different variable on its own? That's fine. There's lots of ways to do these. So, what's the problem? These are my students. This is what I'm working with. If you're a 5th grader from anywhere else in Polo and you're like, why are these kids so dumb? Sorry, this is your future. All right. Anyway, here we are. Use substitution. Which variable is going to be easy scan on its own? X in the top equation. So I'm going to rewrite this as, why am I doing this? X equals 10 minus 2y. Yep. So all of this stuff is going to go into here, and we're going to sub it. No. Why is this a good idea? Why is subbing all that crap in here good? That's right. Now, we'd love to divide everything by -4 so we don't have to distribute and make big numbers, but is everything divisible by 4? No, so we got to distribute. We're going to get -40 plus 8y plus 3y equals 37. This is 11y, and I'm not even going to move the 40 over. We're just going to use our brains. Fam, what do you add to -40 to get positive 37? If you add 42, you get 2. 77, right? Are you seeing it? 77 minus 40 is this. So we know what then? What do we know then? 11y equals 77, and that means y equals 7. And if y is 7, what's this? Yep, this is 14. 10 minus 14 is -4. Good job, Ember. Yeah, I know. It's okay. You're thinking ahead of the game. Turns out this stuff isn't that bad, Jackson, and turns out you're very capable of learning it, and turns out you've gotten a lot better in like 2 weeks. Yeah, you'll be fine. I'm not worried about you. I was worried about you before. But not now. Mm-hmm. Barf bucket, where are you? Gonna be fine. Tough enough. No, I'm good. Not yet, anyway. All right, the things we do for love. All right. Friends, Romans, countrymen. Should we do this one as well? Yes. Which variable is going to be easiest to get on its own? Probably this. We can't use elimination. Let's get x on its own. So this will become x equals 2y minus 4 all over 3. Are you seeing it? Ember, I'm going to send this to you. You're doing less thinking. You're not doing a lot of thinking right now. You need to do thinking. Do you see why this works? Yes. Divide by 3, right? Cool. Now what are we going to do? Yeah. We're going to substitute into the other equation. If you did, it would get back to this, and you'd be getting 3x. Is that 3x? No. You could times it. Well, yeah. Don't. No. You're gonna times stuff you shouldn't.
Can you reorganize the situation?
The situation.
The equation. That's what I did earlier.
What are you talking about? Reorganize the top one?
Yes.
Yeah, you could if you wanted to, but why? To what end? What would that do for you, though? Why is that a good move? I mean, you can. So you can do elimination? Okay. All right, fam. Is 5 divisible by 3? No. Are these divisible by 3? Both of them? No. So what are we going to have to do to get rid of the divides by 3? Yep. This divides out. That's why we did it. And we times every other term by 3. Do we times the 5 by 3? No, it's all part of this one term. 5 times something. We already hit this, right? That's a separate term because of a plus sign. This is separate because it's on the other side. So what do we end up with? Well, we end up with 18y equals 5 times 2y minus 4 plus 12. I would love to divide this term, and this term by 5, but are they divisible? No. So what are we going to have to do? Distribute the 5. This will get us 10y minus 20 plus 12 equals 18y. If I get my y's together, negative 20 plus 12 is negative 8. So that means y has to equal what? This is negative 8. This is negative, positive, what is it? Negative 1, thank you. We found y. Do you see how this becomes negative 8? Do you see how if I subtract that over, I get 8y? 8y, 8 times negative 1 gets you negative 8. So that's why y is negative 1. If y is negative 1, what does this become? Negative 2. Negative 2 minus 4 is? Divided by 3? Thank you. Well, it only took two. It only took two. Only took two. Only took two. I just wanted to make a point. Yes. From today, like homeroom? Yes. That's okay. I'm here to help. All right. So you want to do all of them, right? Yes. So they're saying x is 7. Guess what that means? That means we know 7 equals 6 minus t. Do you know where I got that from? Hey, the instructions. What do you know? X is equal to 6 minus t. So if x is 7, isn't this true? What do you subtract from 6 to get 7? -1. Do you see it? 6 minus a -1 is 7. Oh, brother. So t is -1. That's what they wanted, right? The reading scores are bad. The reading scores are really bad. What do they want? So, but if I know t is -1, and I know this is y, guess what? I know y in terms of t. So if I have t, I win. It's going to be y equals -3 minus 4, which is not 7. Thank you. I know. We're really busting our brains here. All right, so there we go. Do you see how t helps us find y? That's the idea. Oh, Pepper. Don't be copying stuff down. Stop and just think. You'll get so much more out of this if you just relax. How did we get here? How did we get here? No, we got here by doing it your way. I'm going to do my own thing, right? How did that work? Not super great. Maybe she's not like other girls. Maybe she's different than every other student I've ever taught. I don't know, maybe. Or maybe she's like every other student I taught, and you should probably just think more, write less. If x is -3, that means this is true. What does t have to be? Try again. 6 minus what gets you -3? 9. So if t is 9, then we know this. That means y is equal to 27 minus 4, which is 23. Now, here's the kicker, and it kind of annoys me because it's really hard to see where they're getting at, what they're getting at here. But here's the idea. Y in terms of x. That means y equals a bunch of stuff with x in it, right? Is this y in terms of x? That's y in terms of t. If only we could replace t with x stuff, right? What we need is t in terms of x, don't we? If we had t equals a bunch of stuff with x, we could replace the t with a bunch of stuff with x in it, right? So I have this. That's x in terms of t. How do I turn it into t in terms of x? How do I rearrange this to get t on its own? -6 and then times everything by -1, or add t, subtract x. It's kind of weird and it's trippy that they're like so similar, but that's just how it works out. Add t, subtract x. I'm sorry. What do you want from me? All right, so if that's t in terms of x, then that means we can replace all of that stuff for t. Or t with all of that stuff. Hey, look. It's y in terms of x now. That's it. That's all you have to do. I'm going to pause and hit it again, okay? Okay. Check it out. I know this from the directions, yes? If I rearrange it by adding t to this side and subtracting x to that side, I get this. I know it's kind of trippy looking, okay? So t is just this, right? So I replaced t with this. It's your twin, probably. She's calling out to you. Ember. Ember. Huh? Why doesn't he just watch the video? Okay. Whatever. Oh, Dominic. My special little boy. His special little qualities. Okay. Special team, special players. All right. So 3t minus 4 is what y equals, right? Are you seeing that? I replace the t with this stuff. And now it's y in terms of x. I win. y with a bunch of junk with x in it. You could distribute if you want to, but like, who cares? You win, right? You win, so who cares? Who cares? Who cares? Yep. Okay. All right. This says you can use elimination or substitution. We've been doing a lot of subs, so let's do some elimination.
Yes.
I know. When it works, it's great. Yeah, when it works, you should. You should. I want to be clear. When elimination works, you should be able to see it and go for it because it's so fast. But when it doesn't, stop trying to make it work. You can't fix him, girl. Okay?
What if you say like the first one, instead of doing y, you have to get x, but if you multiply the top, x doing top.
Yeah, absolutely. Yeah. Yeah. But sometimes it's really awful. Like, what if this was 13 and this was 51? Actually, 51 wouldn't be bad because 13 times 7. No, never mind. But you get the idea, right? They're so far apart, you might as well just do sub. Sub always takes the same amount of work. Elimination can take a lot. And you're bad at multiplying, let's be honest, because you guys all learn to multiply in a really dumb way. Hi? This. What does y in terms of x mean? Y equals a bunch of stuff with x in it, right? Look at it. Right? Y in terms of x. That's why this is y in terms of t, right? But we wanted y in terms of x. So there you go. You can distribute if you want, but who cares? You're done, right? Now, down here, let's use elimination on this one. Am I going to add or subtract to make these go away? Add them. It's very convenient. That's why these are basic, because they're like free, essentially. If you add these, what variable is going to get eliminated? No, that's not a variable. Yeah, that was very adorable. 7. That was very funny. That was endearing. All right, so the negative 7y plus 7y is 0 y's. X is 4. When it works, you better use it. It's like seeing a screw and using a screwdriver. You should. I know, and it ruined you guys forever because you fell in love with this and you never learned anything else, right? So, pain. I almost wish you didn't do any of it. Anyway, if x is 4, doesn't that mean this is 8? 8 plus what gets you 6? How do I make that negative 2?
7 over negative 2. You got that from my work.
Your answer wasn't right, by the way. Why do we want the 7 on the bottom? So the 7s divide out. Why are they dividing? Because it says divide by 7. Can I show you? Our answers are 4 for x and negative 2/7 for y. This is 8. What's 7 divided by 7? That's why I wanted the 7 on the bottom, because now I do 1 times anything and it gets me the number on top, right? Winner, winner, chicken dinner. The 7 has to be on bottom, so it divides out and I get negative 2. Fractions or division for lazy people. We're going to go to the board and I'm going to do a bunch of pop quiz stuff on this, because you guys need to start thinking this way. I'm going over here. We'll go back. Stop crying. Oh my god. Biggest whiners
When I
ever.
looked up your name on YouTube, I found a bunch of Sudbury games.
This is true. Yeah, I used to do scouting for the Blues. Right.
Is that the right account? Or?
No. Maybe? I don't know. Is that on my Derek McAnally account or is that on my Not a Real Math Teacher account? This is the account you do want. This means not a real math teacher because back in the day I didn't have a degree and I was teaching math, and so people would say, you're not a real math teacher. And I'd be like, thank God I'm not. Math teachers are nerds. Not is 0, just everywhere else, not a, you understand this. Not, right? Not, 0. A, real. So these are the real numbers, that's the symbol for it. So it's just a capital R, just capital R. And then math teacher, not a real math teacher. Okay. All right, cool. What were we talking about? We were talking about this thing. So if I have 5 and I want to times it by something to get negative 11, is there anything nice that you times 5 by to get negative 11? No, we definitely know it's negative. But it's got to become some kind of fraction. Check this out. If I put 5 in the bottom, see how it says divide by 5?
Yeah.
You can divide, and that's gone now. So what do I need in the top? 11, negative 11. So our answer was this part needed to be negative 11 fifths. You put on the bottom what you want to divide out, and then whatever you want on top, you put on top. It's not complicated. Okay? Huh? It wasn't for me when I was growing up either. It turns out fractions are really awesome. I know that's hard to believe. When you add or subtract fractions, it's kind of awful because you need comedy nomies, but anything other than that, they are amazing. Oh, you're following me now. Okay, fair enough. Position 1. Thank you. All right. All right. Now we gotta wait 5 minutes while this all goes away. Holy moly. Yeah, the soundboard doesn't work, but I can still do things like this. I can just pop this guy up. Boom. Burp. Another one. Oh, you can't even see it. Yeah. I got 21 on here. That's pretty great. If I was healthy, I would have fixed this weekend. Oh, that one's my favorite. It's dead. I don't know why. It's probably because I hooked up this guy and he stole it. I don't know. I would have fixed it this weekend if I wasn't like dying, and also everybody's like, "Where's my late work?" And I'm like, that's all I do with my life right now. All right, fam. That and the band concert. So anyway, this one, elimination. I'm going to rearrange it to make it a little bit nicer, and I'm going to move the 2v and the -7. Do you see how I didn't change the problem because they're both still negative? I didn't move it to the other side, so I don't need to change any signs. I'm just switching the order. That's totally legal. I did that so now we can see that elimination is going to be an okay method here. What can I do to make things go away? If I double everything in the top, that'll work here, right? That'll go away. Or I could times all the bottom by 5 and all the top by 3 to get them both to be 15. Which would you rather do? I'll run it by you again. Option 1, times everything by 2, and then these go away, right? Option 2, times everything by 3, so that's 15, times everything by 5, so that's 15. Then these go away. Yeah, I figured, right? Part of being a mathematician, part of being a good math student isn't just I follow the rules. If you do that in this, where you're like, I just do the same thing every time, some problems are going to take you 5 million years and you're going to make a million mistakes, right? You got to find the best way. So the best way is doubling. That's simple, right? So that'll become 10u equals -4v minus 14. And the bottom equation I'm not changing. So that's this. That's totally fine. You don't need to multiply every equation in existence by 2 to make this work. Okay? So now, are we going to add them or subtract them to make the v's go away? Add them, because -4 plus its positive is going to get you 0. So we're going to get 13 u's. And we're going to get -39. So u has to be -3. Are you following me? Yes? Yeah, for real? Okay. If u is -3, because we did elimination, we don't get a nice little equation to plug it into. We have to plug it back into the original. If u is -3, that means this is -9, right? So we know this. You could add 25 to both sides. However, what do you take away 25 from to get -9? 16 minus 25 is -9. How do I, so I know 4v is 16. What, so v is 4. Yeah, that's okay. Calculation isn't really math, okay? Calculation is not math, okay? It's like saying, it's like saying, like, drying brushes is painting or art. It's part of art because you got to do it because it's like how you get your art done and stuff, but it's not art itself, right? Calculation is not really math. So if you're bad at calculation, that's what calculators are for. I don't test you on calculators in here because I don't want you to calculate. I want you to do math. All right, does anybody want to do Tweedledee and Tweedledum? Yes. All right, Tweedledum's talking. I'm going to call him D1. When Tweedledee talks, I'm going to call him D2. Get over it. You can use M and D if you want. I don't care. So, when Dum is talking and he says the sum of your weight, who is he talking about? Dum is talking. He's talking about his brother. He's talking about D2. So he's talking about your weight plus twice his own. What does that mean? Yes. Stop crying. 361. Tweedledee is now talking. He says, contrariwise, the sum of your weight, well, he's talking about his brother now, Dum, and twice my weight, talking about double D2, is 362. Now, you could use M for dumb and D for D. I don't care. What do we want to know? Weigh together, weigh individually. That's the two things we want to figure out. Weighing together is this, right? D1 plus D2. Are you following me on that? Okay, I'm going to pause for station identification. Everybody else is catching up. I know, I'm slowing down. I'm sorry. Chloe. I bought them on Amazon. You can buy the black ones in bulk, which is really nice. And then you can buy the colored ones, but they're kind of expensive. They've gotten cheaper. I think it's like $10 for a pack of 12. So they're a little expensive, but they're worth it. They really are. I learned math on a blackboard with no color, and I did notes in pencil. And when I started using color, I got good at math. Seriously, yeah. What's up? Yeah. Favorite ball player of all time? Are you asking me my favorite or the greatest? The greatest is Jordan. Greatest is Jordan. The best is Jordan. Michael Jordan. It is. You're a LeBron guy, right? So you're a LeBron guy, right? LeBron is very, very, very good. He is number 2, and that's above Kobe. That's really, really good. That's fair. I can understand that. But Jordan is the best, and that's nothing against LeBron. It's nothing. It's really not a bad thing. I am a LeBron fan. This is LeBron James. Okay? Jordan is better, and that's fine. It's okay. It's okay. It's okay. I know that's very unk of me, but, like, it's okay. It's okay. LeBron is very good, and if Jordan didn't exist, we'd be talking about him as the GOAT, right? It's okay. It's okay. There's nothing wrong with that. Okay.
Wait, why are you adding that? Because it says weight together.
So check this out. Your weight plus twice mine is 361. Your weight plus twice mine is 362. This is what they gave us. What do we want to know? How much they weigh together? That's this, right? And we also want to know how much they weigh individually. So that's this. Don't lose track of what you're trying to find. Keep your eye on the ball. So, I'm going to show you something slick. Are you ready? I'm going to add these. Does anything get eliminated? No. So what I'm doing is not elimination. So why am I doing it? Check this out. Check this out. Check this out. There's something really slick with this problem that I noticed. If I have one D2 and I add another 2 D2s, how many do I have? If I have 2 D1s plus another D1, how many D1s I got? 3 D1s. And that's going to equal 723. That's 600 plus 120 is 720, and then add 3, right? I know, where was that in 8th grade or whatever you were going to say, Chloe? There are so many better ways to do calculation. I hate calculation, but the ways we do them are like the most idiotic, and that's not your teacher's fault. That's just... All right, check this out. How is this going to help me with any of this? Do you see it? If I divide everything by 3. Yep, if I divide everything by 3, I get what they weigh together, right? Now, is 723 divisible by 3? If it is, we're really good. If it isn't, then we get fractional answer, and that could happen, right? What if they're not exactly the pounds? It is, because this is really, check this out. I'm going to do this over here. 723 is 600 plus 120 plus 3. So if I ask, is this divisible by 3? It is if this is. It is, isn't it? Right? So that's 200 plus 40 plus 1. 241. Long division is for fools. Thank God. Long division is stupid. It's so dumb. It'll take you 20 minutes to find out what, like, how many times 7 goes into 77. I said it. I think the more I write, the more confusing it can get, because then there's marks everywhere. What? I can't tell you what that's from, because if I tell you what it's from, I will be very ashamed of myself. But this right here. I had a friend in school who used to say their words really weirdly, and that was how they said what, and it was because they were deaf. Wah? That's how they would talk, and we used to joke about that all the time. But, yeah.
Well, was he a friend or?
They were a friend. They were a friend. It's like my one friend that had testicular cancer is like a junior in high school. He was a twin, and so one of the twins had two, and one of the twins, or the other one had one. That was funny. That's how we used to joke that's how we tell them apart. He had testicular cancer.
Please don't explain it. Please just do that.
All right. Bam. Together they weigh 241. Check this out. Here's why I think it's really slick to do this first. I'm going to rearrange this.
Here's the gum. No.
Uh-huh. I did it on purpose.
I know you did. What is the gum doing for you?
It's popping my ear. That way I can hear out of my ear. Because I'm having trouble hearing you guys. This is my good ear, and it's the one that stopped up. All right. So speaking of people that are deaf, right? Anyway. Do you see how this implies this? Why is that good? Because we can substitute that in here. So check this out. Instead of writing D1, I can write 241 minus D2 plus 2D2 equals 362. ASMR, Chloe Majors. All right. Why is this a good move?
Why did you do this?
Why is this a good move?
So we have
One variable. Negative D2 plus 2 D2s. What's that going to come out to? 1 D2. What do you add to 241 to get 362? All right, pause. Do you see how I got from here to here? D1 is all this crap, right? If I plug that in for D1, I get this.
Wait. Oh, I see it.
Yep. You have to ask questions like that. You have to. It's so no. If you don't ask these questions, you're going to be stuck on something this dumb. That's stupid, right? You have to ask these questions. Okay? All right. So now, after we combine these like terms, we get this. So the question is, what do you add to 241 to get to 362? So we know that D2 is 121. All right, check this out. If D2 is 121, then we know D1, don't we? What's 241 minus 121? 120. You win. And they do both add to 240, right? So we're good. We got them. Ladies and gentlemen, we got them. Obama. What is Obama's last name? It's a meme because most people forget that it's his last name. Barack is his first name. So if you said Barack, you're wrong. His last name is Obama. Yeah. All right, my parents started a small farm after they retired. This is not financial advice. On their farm, they have chickens and pigs, E-I-E-I-O. In total, there are 40 animal legs. Okay, so chicken legs plus pig legs equals 40 legs. That makes sense. There's a problem, though. Do they want to know how many chicken or pig legs there are? What do they want to know in this problem? How many chickens? So our variables should not equal legs. So C shouldn't stand for legs. C should equal the number of chickens. That's what we want to find, right? And if C is the number of chickens, P should probably stand for what? Number of pigs. So is it true that the number of chickens plus the number of pigs is 40? No, that's legs. Traditionally speaking, how many legs does a chicken have? So if we double the number of chickens, we get chicken legs. How many legs does a pig have? Traditionally speaking, yes. So now we have legs plus legs equals legs. That's good. Now, they also said that there's 16 heads. Traditionally speaking, how many heads does a chicken have? One. So this is totally fine. Traditionally speaking, how many heads does a pig have? One. So this is also fine. Hey, look. All right, can I show you something big brain? A lot of you guys are thinking, oh my God, elimination, let's double it, right? But that gets rid of C. What do we want to find? How are we going to find C? We want to find C. So why eliminate C to find P and then plug it back in to find C? Why don't we eliminate this and just get C and stop, right? Like, why get rid of this by doubling it and subtracting and get P and then take P and plug it back in to find the thing we really care about when you could just eliminate this by timesing it by 4 and then you get your answer for C. You don't even need to know how many pigs they have. So let's do that. Let's times everything by 4 here. This becomes 4C, 4P, and 16 times 4 is 40 plus 24, 64. Are we going to add or subtract these to eliminate this? Danger, warning, danger, warning. I know, right? It's because we're both quoting the same old TV show. I never actually watched it because I'm younger. All right, so this right here, you have to subtract stuff. You guys forget this all the time. So this is not going to become 6C. What is it going to be? Negative 2C. 2 minus 4 is negative 2. C. Don't forget your variables. Stock them on Instagram. What is 4P minus 4P? It goes away. Do not write P. P means 1P, not 0P. 40 minus 64 is what we're doing. We're not adding these. 40 minus 64 is? Thank you. So that means C must be 12, and we win. I don't even need to find P, but just for fun, how many pigs are there? If there's 12 chickens, 4, right? Yeah. Wow, truly he is the greatest of all time. Okay, turning the page. We're on the intermediates. Yes, no, maybe so. Oh, apparently I already did some of these. Did I do these with a different class? Yes, you may. I'm going to grab a clean one. All right, so let's do the intermediates for 5. Buckle up. Okay, this says find 3 different ordered pairs, not 5, 3 different ordered pairs that satisfy both equations. Now, if these were 2 random equations, there should be 1 and 1 answer only. But what's special about these 2 equations? They're the same. If you times by 5, you get the same thing. So there should be infinite answers. I want you to find 3 of them, okay? So anything that works for this one will automatically work for that one, right? So why don't we just focus on the easy one? Because we know it'll automatically work for the other, right? Can anybody give me a number for X? It doesn't have to be nice numbers. You can just give me a number for X. 2. Okay, cool. We don't fear fractions. Fractions fear us. That's a Lexi, or fractions fear me. That's a Lexi Kristen quote. I'm glad that Lexi feels that confident. Fam, what's 3 times 2? I want everybody to stop and think. What do you, stop. What do you take away from, stop and think. It's 2 parts. Stop. Okay, that's good. Keep it up. And now think. 6 minus what gets you 1? 6 minus 5 is 1, right? So what do we know? 7y must equal 5. So y has to equal, what do you times by 7 to get 5? 5 over 7. So the 7's divide out, and you get 5. I will show you. I will show you. Is 7 divisible by 5? No. So we do 7 times 7, which is 49, and then we divide it by 5. Is that what we wanted? No. What if I do 7 times 5 sevenths? Is 7 divisible by 7? So we get 1 times 5, which is 5. That's why. It's super important. Until you see it, it's going to feel weird and impossible, but once you see it, it's so obvious. All right, and that's going to be super important when you get to Algebra 2. Super. That seems excessive. Like, why think so hard when think simple do better? Yeah, that doesn't make any sense to me, but okay. You do you. Okay? We've been doing so well with the whole I'm gonna do my own thing strategy. Let's just keep that up. Okay, cool. Give me a number for x. I heard 5 from Ember. Why does Ember want this to be 5 times 3? That'll be 15. But okay. Oh no. That doesn't matter. That doesn't matter, Ember. That's a coincidence. Here's why 5's a good number. What is 5 times 3? Okay, 15 minus something is 1. 15 minus, not 2. How do I make this 14? Y would be 2. I did not do that. That was Ember crunching a trolley bright crawler's bag for you, ASMR style. All right, cool. So that was weird. Guys, give me another number for x so we can just be done with this. I don't care what it is. 7. Fam, this is now 21. 21 minus what gets you 1? Okay, fam, that's 15. 15 minus 14 is 1, right? I make it 14 by putting a 2 in. 7 makes this 21. 21 minus what gets you 1? So what do you times by 7 to get 20? I win. I don't fear fractions. Fractions for me.
Why did we do fractions?
Because fractions are easy if you understand them. It allows you to just find answers really fast. If you try to look for nice numbers, it could take a really long time. Hi. Decimals suck. Decimals suck so bad. Maybe your grades had nothing to do with your mathematical understanding. All right. It's totally possible. I did high school as well. All right. And middle school. So anyway, why is it not possible? Because it says, is it possible to find a number that works for the top but not the bottom? No, because it's the same equation, right? If it works for the top, it'll automatically work for the bottom because they're the same. Right? Are we cool? Okay, awesome.
Can we go to chapter 4 now?
No.
We're going to do this entire passage with what we have not decided to compare ourselves.
Whose problem is that? Yours. Your problem. All right, cool. This one is saying, if I know that this equation right here, one of the answers to this equation is this, ew, how can I quickly find more answers? Here's how. Here, Jackson knows, but here's how. Okay, this is your delta y. Okay, why is that? Because we talked about it and we learned about it and nobody paid attention, and now you're going to have to learn it in chapter 8. No, this is intermediate. So that means delta y means that we add 2, we'll get another answer. This is sort of your delta x. One of them has to change signs. There's a way to prove this, and I can do it in a second if you really want to. But if that's delta x, that means we're going to add 5 because one of their signs has to change, and that'll instantly get us another pair of numbers that'll work. Guaranteed every time. Okay? So that's what you're going to write down in your own words. Does that make sense? Now, why is this true? Can I prove it to you? All right. What I want is I want something that we can add to our x value. So imagine we have an x that works, right? Like this x, right? If I add a certain amount to it, and I add a certain amount to the y that works, I want it to still equal negative 3.1. So what do I need to add to x and y that won't change the equation? That's the question. Well, it turns out it's going to be 5 and 2. Let me prove it to you. If we distribute, are people crying? Stop crying. Check this out. The question we're asking is how much do we change y and x by so that it doesn't actually change the problem? So, in other words, we want we want these to go away so we get back to the original. Does that make sense? So right now, do these subtract to 0? No. What number could I plug in for delta x and plug in for delta y that would make these go to 0? If delta x is 5 and delta y is 2, these will both go away, won't they? Look familiar? 15 and 6 would have worked as well. 30 and negative 30. Any relationship that's 5 to 2 would work. That's our change in y and change of x ratio. Notice that these come from here. Because the 2 that is here is going to affect, it's already going to have a 2 here, and this won't. So what does delta y got to be? It's got to be the thing that makes up for it. Delta x needs to be the thing that goes with this 5. Well, it's got to be the thing that goes with this 5. It's got to be 2, right? So that's the idea. We want both of these to go away. This has a 2, give it a 5. This has a 5, give it a 2. Boom, there you are. Now, we're going to talk about that more thoroughly when we get to Chapter 8, and you're actually going to understand it because we're going to teach slower. Next semester, I'm going to do slower. Just don't tell anybody, okay? Just tell no one. It's a secret, okay? We're going to do it my way. We tried doing it the other way, and it, like, worked kind of, but you'd be so much smarter if I just slowed down and taught you where you're at instead of forcing you to be where somebody else wants you to be, okay? All right. Does anybody want to see this one? Here's what I'm going to do. I'm going to compromise. We're going to turn this into a basic problem, and after it's a basic problem, I'm going to say, then you solve. Because you've already done the basic version of this. Can I show you how to make this into an easy problem? And then I'll be like, then the rest is up to you. Is that okay? If you've already proven it thoroughly that you know what you're doing on the basic versions, then I don't need to see it again. You can just stop. Yes. So let's turn it into an easy one. I would love, since this is an equation, to times by something that's going to be divisible by 6, 2, and 3. What is the smallest number that's divisible by 6, 2, and 3? 9 is not divisible by 6 or 2. 3 is not divisible by 6 or by 2. 1 is not divisible by 6, 2, or 3. It's 6. I'll show you what I mean. If I times by 6 to every term. You guys love to say cancel, and that's what... Stop. You guys love to say cancel, and that's why you guys suck at this stuff. So stop saying cancel. It's almost like I'm right about all this. All right, fam. See how this is one term? We can either times first or divide first. The reason we did this is because we know 6 divided by 6 is what? 1. It doesn't cancel. 1 times 5s is what?
5s.
Do you see how the 6's go away? Now, it's not always going to go away because is 6 divided by 2 just going to get rid of the 6? Nope. What is 6 divided by 2?
3.
So we get negative 11 times 3, which is negative 33. I'll pause. Are you seeing why timesing by 6 was a good idea? It's divisible by 6. It becomes 1. It's divisible by 2. It becomes 3. And we get whole numbers. Yes, the numbers will be bigger, but at least they won't be fractions. Now, what happens when I times this by 6? What's 6 divided by 3? So what are we going to get? Negative 4r. That's why you don't say cancel. Reason 1 of 5 million. And this isn't even the best reason why you don't say cancel. This is like a mediocre reason at best. But it's still really good. Stop saying cancel. All right, now in the bottom. Different equation, so we can treat it differently, right? What number is divisible by 3 and by 9? 9, also 18, also 27. But what's the smallest number? 9, right? Let's just times everything by 9. Every term. You can do this because it's an equation. Do you see the equal signs? Yeah. Everything is 9 times bigger now, but it's still equal. That's fine. If this wasn't an equation, everything being 9 times bigger is a different number. You can't do that. So you'd have to get commie denomies. Here, because it's an equation, just go ahead and times. It's totally fine. 9 divided by 3 does not cancel. What is 9 divided by 3?
3.
So we get 3 times 2r, which is 6r. Are you smelling what I'm stepping in? 9 divided by 9 becomes 1, which basically cancels, right? 1 times 28 is just 28. But if you understand why it does that, why are you using the word cancel, right? Like, just say what is happening here. 9 divided by 9 is 1, and we get 1 times 8s, which is 8s. Now, before we move on, you should always ask yourself, can I simplify any more? That's what's going to make these problems doable. Also, double check to make sure you didn't goof this. So many mistakes happen going from here to here. On the basics, the intermediates, the advanced, you're good at doing sub and elimination. What you're bad at is simplifying, all right? For the love of God, check it. You're going to spend 20 hours down here trying to make this thing work when you made a mistake because you missed a negative sign here. So let's check it. 9s divide out, we get 6r. Love it. 9s divide out, we get 28. 9s divide out, we get 8s. 6s divide out, we get 5s. 6 divides to 3, we get negative 33. That's good. 6 divides out to 2, we get negative 4r. What do you notice about the bottom equation? We might as well do that because that'll make life a lot easier. All right, so I'm going to zoom out and I'm going to move it over here. Are we in focus? We're not, right? Yeah, we are. in focus. All right, so now we're going to get top one I'm leaving alone. There's nothing I can divide out here. But if I divide the bottom by 2, it's going to be easier to work with. Smaller numbers. Yay. So now we're here. All right, fam. From this point, you do elimination or substitution and you win, yes? See how this is like a basic problem on the beginning? Divide by 2. So from there, you do elimination or substitution and you win. Do you want me see me do it or no? Okay, then I won't. I'd probably get S on its own, divide everything by 4, plug it in there, yada, yada, yada. R is like 10 or something. I don't know. Anybody want to see how to make this one simpler to work with? Down here. They're all decimals, right? Do you see how we have 0.2x? Did you know 0.2 is the same thing as 2/10? So what can we times by to get rid of this? 10, right? 0.1y is the same thing as 1/10 y. So what can we times by to get rid of that? 10. 8.8 is the same thing as, is the same thing as 88 over 10. Because that goes into it 8.8 times. So what do we times by to move that decimal place over? 10, right? So I'm going to times everything by 10. And I'm going to get 20x minus 30y equals negative 32 minus 2x plus y, 1y. It just so happens that timesing by everything by 10 in the bottom is also a good move, right? Yeah. Am I good? Okay. The bottom one, which I'll do in like blue or something. Okay, this is the blue equation. Becomes, after I times it by 10, 10x, 6x, minus 10y, plus 88. This is where most of the mistakes are made, guys. Double check to make sure you didn't goof. Now we're going to combine like terms. You could divide everything by 2 in the bottom. That would be kind of nice before you do it, but it's up to you. So let's combine like terms. If I add 2x over, I get 22 x's. For some of you, that's a lot of x's. For others of you, that's just 1 year. If I subtract y, I get negative 31 y's. And I get this. None of these divide out, so I'm just stuck with those numbers. Sucks to suck. I don't know. If I subtract 6x, I get 4x. And if I add 10y, I get positive 10y. And that's going to equal 88. What do you notice about the bottom equation? We can divide everything by 2. So that's going to become this. Notice I have not even done elimination or substitution yet. I am only simplifying. That way my life will be easy when I actually do it. Simplification is for you, not for me. So there we go. Now, I would probably do elimination, just times everything by 11 in the bottom. I know it's going to be gross, but it's not that bad. It's 484, big deal. That's 55, that's 22. And then subtract them. But from there, it's a basic problem, right? We cool with that? Okay, cool. Christina, are you okay? Okay. Do you need to go home? Okay. Okay. Because if you're just going to, do this the whole time, you might as well do that at home. Which is totally fine. I'm not mad. Okay. So yeah, from there we do elimination, substitution, right? And then we win. That's the idea. That's the idea. Get it to a basic problem, and then we know how to solve that. Cool. Oh, it's busting the mic. That's not good. Here, I'm waiting on Ember. She has to write everything down. My little guy. No. No. We don't do requests on my ASMR channel. Sorry. I am the artist. I do not have slime. But you would be so into slime. Oh my god, look at you. You were so into slime. Yeah, I'm right about you. That makes a lot of sense. Oh my god, she still is. Okay, anyway. Are we doing this one or no? I've come to the conclusion that you guys are too dumb to get any of my jokes. Sometimes I think I just need to be like 6, 7, and then you guys would be like, oh my God, yeah, look, right? It's the international joke. If I do dumb jokes, you guys, yeah, I know. It's absolutely incredible. I've realized that using big words like, I don't know, concept, I feel like that's too big of a word for you guys. That's insane to me. You guys need to read a book, like an actual book. Okay? Read actual books, not like one of us is lying or something. Stop at that, okay? Don't read that. Stop reading fan fiction, okay? Pick up Tolstoy. Read Of Mice and Men. Read Scarlet Letter. Read Chaucer. Read Wuthering Heights. Read Scarlet Letter, okay? Okay, anyway, this is why you are dumb, because you do not read. Okay, what do you notice about these two equations?
They're like 5.
If I rearrange the bottom, it's going to be more obvious. 6x plus 10y equals 40. And if I rearrange the top a little bit by just shifting which one's there and there, what do you notice? If you double the top, it's going to be this, right? Are they the same equation? No, they are not. If I double this, I get this. They're almost the same. How can 6x plus 10y equal 40 and it equals 130? There's no set of numbers that make it work. If you were to do elimination, you'd get 0 on this side because everything would go away, and you get negative 90 over here. Does 0 equal negative 90? No, it's impossible. So either you goofed or what they gave you can't be true. There's no way that these can both be true. Always simplify first because it'll save you a ton of work. Basically, that's what this is getting at, and all you need to know is that, yep, no solution. Is it always no solution? No, sometimes it's infinite solutions. Depends on what I change the number to, right? So there we go. If this equaled 40, then they'd be identical, right? So that means literally anything works. So that'd be infinite solutions. Are we cool with that? Robeson wasn't paying attention. I'm sure this will go over well tomorrow. All right. Fam, I'm skipping these ones because it's the same thing as last time. Times everything by 13, distribute the negative 2. Times everything, it turns out by 13, distribute the negative 5, right? After you rearrange it and simplify, it'll be a basic problem. What can we times by here to get rid of decimals in the top equation? 2 works, or 10. 100 would technically work. Yeah, but 2 would probably be the easiest, right? Double that, double that, double that, right? In the bottom, timesing by 100 would work because it moves it over twice, right? That's 75 hundredths. But did you know there's a better way? This is 3 3/4, right? That means this is 9. Let me say again. This is 15 quarters. Right? 12 quarters here, 3 more quarters there. So what can we times this by to get rid of it? 4. If you times this by 4, you get 15. So timesing everything by 4 would be the easiest move here, actually. If you want to times by 100, knock yourself out, and then you can simplify afterwards. But the simplest move is times by 4. Okay, so get rid of decimals. Times by 100 is safe, though. Okay, times by 100 moves everything over 2 spots. Ember, are you smelling what I'm stepping in? Okay. Next, describe all solutions. Danger, warning, danger, warning, danger, warning. Guys, if it has one solution, you would just give me it, right? If it says describe all solutions, it probably has infinite. That would describe it. Or it has none, right? So let's take a look at this. If I rearrange the bottom equation, I can get 14x plus 21y equals 49. Are these the same thing? They are. You just times it all by 7. So how many solutions do we have? Infinite solutions. Literally anything that works for one works for the other. In the bottom, let's get rid of fractions by timesing everything by 5, right? Now we get 3x, because 5's divide out, and we get 1 times 3x, which is 3x. 5's divide out, we get 1 times negative 4y, which is negative 4y, and then this is 15. I'm going to rearrange the bottom equation to make it a little bit easier to see. Do you see I'm not moving them to different sides? So now I'm here. If we double the top, times by negative 2, it'll match, right? But will this match? So no solution. Yes. So this will never match the top, because even if we times everything by negative 2, the top will become negative 6x, love it, positive 8y, love it, negative 30. So how can negative 6x plus 8y equal 5 and negative 30 at the same time? It can't. No solutions. If you did elimination here, you would add them. Sorry, you'd subtract them. Everything would go away. You get 0 equals negative 35. Not true, right? Okay, do we want to see this one? Yes, you want to see it? Okay. It's really easy if you know how to do it. It's really easy. It's like 3 points. I'm going to do it anyway. It wants to know when will these have infinite solutions. Well, that means both equations have to be the same, right? Let's rearrange the bottom. They want to know what A has to be that makes this the same. Well, first off, we have to times everything by 3, right? So that means this part is going to be negative 24. So if that's negative 24 and this is negative 24, then they'd be infinite solutions, right? So what does A need to be so this becomes negative 24? Because then everything will match. Negative 40. Negative 40. Can I show you guys how you can subtract that? Are you ready? We're not going to go right to left. We're going to go left to right. What's 10 minus 40? 10 minus 40. Negative 30. Okay, do not drop a 0. Don't do anything. What's 6 minus 0? Put them together. Wait, hold on. We get negative 24. Why did I get negative 24? Did I do the wrong things? Negative 30, 6 minus 0. What? Oh, wait, I want it to be negative 24. We're good. We're good. We're good. We're good. We're good. We're good. I thought it needed to be negative 40. That's this. Okay, we're good. I'm just losing my mind. We're good. We're good. Okay. Cool? All right, we need negative 40. Eric and Bob, yes or no? And then we can do the balls problem.
We're good.
No Eric and Bob?
Wait, so if I put like everything all in, not divide,
Can't hurt you. It'll keep you the same at what you already are, which is what? Not good, right? Well, yeah. But it'll leave you the same as what you were before you took the final, which is 40s, yeah. He's early. We've only been doing this for an hour and a half. Dude, we're like flying. Chapter 5 takes the longest. That and chapter 1. All right. Eric and Bob, yes or no? On God? Balls, yes or no? Okay. Because it has a really nice solution you can solve in like 5 seconds. All right. Area of the square, finding the perimeters and stuff. What about Janice with the time? We might have. I don't remember. I think so. Janice, A plus 15. Yeah, we did. We did, right? Yeah?
Yeah.
I did it with one class. It might have been with the Algebra 2 class. Okay. By the way, Algebra 2 does Chapter 4 and Chapter 5. So if you watch the review, you might get Chapter 4 and Chapter 5 on there. So that could be handy. Yeah. Well, I mean, you don't have to go. You can watch the video, right? Okay, whatever. Turning the page. Yes, no, maybe so? All right, here's the idea. Here's the idea. Fam, when we have a problem that looks like this, what is our goal? What is to get one fewer variable, right? So what are we going to do here? Hold on. I lost it. What's going to be our first goal? Get one fewer variable. If we can turn it into two equations, equation 1 and equation 2, that each have two variables. Let's say they both have x and z in them. Don't you know how to solve a problem like that? right? It would be just like we did on the basics. You have an x and a z, you do elimination substitution, right? So goal 1, get 2 equations with the same 2 variables. In this one, I'm going to get x and z on their own because, look, I can very easily get rid of y's. Are you seeing this? I'm going to pick this equation and this equation to make my first equation. So check it out. I have x plus 3y plus 2z equals 6. And I saw that elimination is going to work really well with this one, which is why I chose them. Plus z equals 14. Am I going to add these or subtract these to make negative 3y and 3y go away? Add them. Hooray for adding. It's easy. What's x plus negative 2x? Negative x. 3y plus its negative is 0. And then this becomes 3z. If you're not paying attention right now, can you get Dom or show Dom what he needs to do? Thank you. Or you can just get it for him. I don't know. It's up to you. All right. Fam, do you see how I did this and I got an equation with x and z in it? Got my first equation. I'm going to write that over here. It's kind of gross looking, but it's okay. Remember, our whole goal is to change this to a problem we already know. Now I'm going to pick equation 2, and I'm going to pick equation 3 again. And that's going to get me my second equation because I can eliminate y's here if I'm careful, right? All right, I'm going to do a big pro gamer move. I'm going to times everything by 3 right now in my head. That way I save space on my paper. You are not a pro gamer. You will make a mistake here, and you will cry. So write down all your work, and then times everything by 3. I'm a pro. If I times this by 3, I get negative 9x, positive 3y, positive 15z equals 87. If I don't mess with the bottom equation, I get this. Am I going to add or subtract those to eliminate y? Am I going to add or subtract these to eliminate y? Adam. Why did I want to eliminate y? Because I want 2 equations with the same variables. I don't care if it's like, but this one's really easy to get rid of x. I need x. I got x in this one. It does you no good if you have y and z here and x and z there. You have to have the same variables, right? So if I do this, I'm going to get negative 11x. This goes away. I get positive 16z's, and I get 101 over there, because that's 90 plus 11, which is 101. So here it is. It's kind of gross, but here are my 2 equations. That's a 16 equals 101. Thank you. Don't lose your X's. Stalk them on Instagram. All right, fam. Do you see how this is like a basic question now? Right? Now you do elimination or substitution. Times everything by 11. Add them up or something. I don't know. Right? Yes? Once you get it here, if you've proven yourself earlier on quizzes or on the final, then if you've proven yourself that you can handle problems like this, you can just stop now. However, I'm going to do the rest of it just so you know what happens, because it's actually not that bad. Yep, I would actually do sub. Yeah, you're right. So the goal is to turn it into a problem we do know. Sorry, did I move that? Do you need to take a picture? Okay, cool. All right, so the goal is to get it to a problem we do know. Do we see how this is something we know how to solve? Right, you do elimination substitution. I'm going to do it right now. I'm going to take that first equation and write x equals 3z minus 20. I want you to pause. I added x, subtracted 20. Are we cool with that? Add x to the right. I put it here. Subtract 20 to the left. I put it here. Yes? It's a little trippy. All right, if I know that, I'm going to take all of this and plug it in here. Why is this a good move? Okay. Why is this a good move? Because now we have only one variable. And we can find z. And once you find z, you're going to get the other ones really fast. So this is, I'd love to divide everything by 11, but I can't. So I'm just going to distribute negative 33z plus 220 plus 16z equals 101. After I rearrange these, this is negative 17z's. Thank you. This becomes negative 17 because I'm just putting them together. Right? They're on the same side of the equation. And if I subtract 220, I get negative 119. If you had to guess, how many times does 17 go into 119? Is it 10 times? 7 times is the right answer. 10's too big. That gets you 170, right? So you know it's less than 10, unless it's just a fraction, right? It could be 119 over 17. Hopefully it's not, right? But 7's really good guess, because what is 7 times 7? It ends in a 9. So that's probably a good guess. And it's true. Check it. What's 7 times 10? 70 and 49 makes 119. Nailed it. Z is 7. Right, it's already negative because of this thing, so it's 7. If Z is 7, what's this? 21 minus 20, which becomes X is 1. If X is 1, that means this is 1. If Z is 7, that means this is 14. So I have 15, right? 15 plus what gets you 6? Negative 9. How do I make that negative 9? Y is negative 3. I told you, the last two variables are going to be like boom, 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 okay? All right, this is another example of the exact same thing. I'm going to point out something really nice, okay? Just real quick, I'm going to point out something nice. If you times the middle equation by 3, and you add it to this, don't you get Z for free? Triple, 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 triple. Add them, those all go away, and you just get Z for free, right? That's really nice. You should notice things like that. That's pretty sick. All right, now we're on to spicy. Yes, no, maybe so. Okay, cool. This one's really easy, actually. All right, everybody learn. Why is this true? They both equal 273. I substituted 273 for this. They're equal, right? So now if I get my p's together, I get 1p. And if I add that over, I get 1q. I get this. What does that mean? P, same thing as q. That means my original equation, I don't have to write as 92q anymore. What can I write? 92p. Why is that a good move? And I get negative 79p equals this. Our answer is going to be a fraction. P is going to equal 279, or 273 over negative 79. And Q will be the same thing. That's an advanced problem. If advanced doesn't mean hard. Advanced means you have to know how things work, and if you know it, it's easy. If you don't know it, it's impossible. Can I show you another advanced one? How do we know this will have not infinite? How do we know this won't have infinite solutions? Yeah, it's not the same thing equals the same thing, right? How do we know it's not no solutions? Yeah, if it was ax plus cy equals d and ax plus cy equals e, that's impossible, right? So it's going to be one answer. Boom, done. Use words. This looks really tough. What can we do? You could totally multiply to get rid of fractions because they're equations. Can I show you an easier way? What if I triple everything here? I get this. This is something one of my first students thought of, Zoe Wyatt. And I did not think of this. But this is definitely what the book wanted you to see. Why is tripling everything in the bottom a good idea? Yeah, it does. It does here. If we eliminate by subtracting, that'll go away, right? They have common denominators, so we can put them together. What's anything minus itself? 0. We're minusing a negative 15, so it's really adding. We get 22 over, whoops, I wrote an X. It should be a Y. Thanks, Pepper. All right, so this should be 22y over y. And 4 minus 48 is not a positive answer. What's 4 minus 48? What do you divide 22 by to get negative 44? Don't say 2. Don't say 2. Don't say 2. That gets you 11. A half fits into 22 44 times, right? So y is negative a half. Cool. If y is negative a half, then we have this. I'm using the bottom equation, right? How many times does a half go into 5? And it'll be positive, won't it? Fam? What do you add to 10 to get 16? 6. What do you divide by 2 to get 6? Yeah, a third goes into 2 6 times. 2 goes into a third fits into 2 6 times, so we win. All right. Anybody want to see this one? On God? I think Jackson could do it. Let x equal blah, 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 let y equals blah, 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 or just move it around. Yeah, it is an incredibly powerful thing. And right now it's like not necessary 100%, but it helps you visualize things better. And then later on it will be like the biggest of the big brain. Okay, anyway. So that's a no? 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 You want to see this one? Magic square. Rows, columns, diagonals all add up to the same thing. We want to find y plus z. Guys, check this out. I know this, whatever it adds up to, will add to the exact same thing as this. So I'm going to write that down. Now, why did I pick those two rows, or that row and that column? Do you see what will happen if I subtract v from both sides? You want to pick one that has a matching variable, right? And then nothing else. So now we get this, which is 43. So what does w have to be? 19, right? Now I know that's 19. Okay, cool. So that means I can now pick, like, let's do this and this. Are you seeing it? They both share an x and nothing else. So 19 plus x plus 25 equals 24 plus x plus z. Now, why did I choose something like that? Because the x's go away, don't they? X's subtract. And I get 44 equals 24 plus z. So what is z? 20. So z is 20. Hey, guess what? I know what all the rows and columns add up to now. All the rows, columns, and diagonals add up to 45 plus 21, which is 65. So v is 21, is that true? 46 plus 18 is 65? No. 22 gets us 20 and 40, so yeah, it's 22. V is 22, which means x got to be 43, that's going to be 22 as well. And y's got to be, that's 40, so that's going to be 25. So these two put together, 45. That's what they wanted to know, y plus z. Eventually you'll have to notice, oh, I know what they all add up to now. If you don't do that, you're going to get stuck. Okay? That was basically all the spices that matter. I hate this problem. Turns out the spices aren't bad if you know what you're doing, but they're impossible if you don't. Like, if you don't understand what's actually going on. You can't BS your way through them. All right, we want to go to 4 now, huh? Okay. Everybody has a 4 in front of them? Yeah. Okay, 4 basics. If you've done 1, 2, and 3 already, 4 is going to feel like a joke. It's going to feel really similar to 2. The difference between 2 and 4 is this. 2 is like, okay, what if there's one variable and you have to plug stuff in? 4 is like, what if there's more than one variable and you have to plug stuff in? Oh, not that difficult. All right, fam, I swear to God, Chloe Majors, you do this. Everybody, like, tries to do this stuff individually. Stop. Instead, write it out, and wherever you see an X or a Y, leave parentheses. Do. X is 5. You're better at doing this now. I had to break you, though. Who's really bad about this? J-Boss is really bad about it. It's not. I don't like it either. It offends me. It makes me upset. You can't come up with your own nickname. It doesn't work. You can't be like, everybody call me Ace now. Like, and no one calls you it. Why? Because you made your own nickname. In middle school, that joke would have killed. All right, so anyway. Because it was so awesome. Nobody, like, yeah, good one. What's -2 times -2? Hey, look, the answer's 9, isn't it? Show your work or I will find you. All right. X is 5, right? And hopefully the no notes thing will help you guys. You know what you guys do most of the time on these? You use the numbers from your notes here on accident. Pain. Pain. Fam, do you distribute here? No, it's all one term. Why am I seeing you guys distribute the 3 to... Stop. No. This is 15 times negative 2. Is that going to come out negative or positive? Negative 30, right? There we go. It's a cool looking 3. All right. Down here, this is the epitome of like, I'll just keep doing it one bit at a time instead of plugging stuff in like I should. And then you guys get trounced. So 2 times whatever x is, y squared. I'll write it like this, why not? Did you know the square only affects the y and it only affects the x? It's true. This is true. True story. What does it mean to square something? Yep. So I'm going to write this out so I don't make any mistakes. If you guys do this, watch. A lot of people tell me this is negative 10, then square it. What does negative 10 squared mean? Negative 10 times negative 10. But if I write this out, do I end up with negative 10 times negative 10? No. So that's why you don't square first. Or sorry, why you don't multiply first. You have to square, right? Because squaring means timesing. You have to write out what it means. So this is not negative 50 or negative 10 squared. This is 5 times 5 times negative 2. For the love of God, okay? You know you're going to mess up negative signs here. So why don't we take care of that first? Will this come out negative or positive? Positive. This is positive 4 times a bunch of other positives, so it's definitely positive. What about this one? Definitely negative. So this is 25 times 2, which is 50, and it's going to be negative. This is 10 times 4. That's 40, which is positive. What's 40 minus 50? Are we good? Okay. I'm going a little quick right now. I should probably slow down a bit. Sorry, I'm getting excited. I've also done this like 3 times in the last however many days, so I'm getting a little like... All right, fam. So many of you guys make this mistake. You distribute. You distribute. Why are we distributing? What does it say to do? Yes, don't say simplify. Add. We're adding them. First off, I show this every time, and someone new sees this, and it changes their life. You know you can add them like this, right? 6 B's, negative 4 A's, yeah? All right, now, do you want to do that? No, you don't, because eventually it's going to get so messy, you're not going to want to write all this out. So let's just think. 4 B's, and we're adding it to 2 B's. That's 6 B's, yeah? Everybody says this is 7A, and it's definitely not 7A. It's negative 7A. And we're adding it to 3A. That's negative 4A. Are you smelling what I'm stepping in? Cool. What does it say to do here? So distribution is when we multiply. Are we multiplying? So we're not distributing. We're adding them. Add them. Fam, we're going to add like terms. 9Z, can we add it to 2Y? 9Z, can we add it to negative 9Z? That's actually 0 Z's, isn't it? Do not write Z. Z doesn't mean 0 Z. What does Z mean? 1 Z, and it's not 1 Z. Ha ha ha, 1 Z. Negative 2Y, and we're adding 2Y. That'll work. It's 0Y. Oh my God, it goes away. Will they always go away? No, Mr. Mac was just feeling funny. 6X, which is positive, right? And we're adding it to 3X. How many X's? 9 X's. Yeah, not always will everything go away. Not always will anything go away. I just thought it would be funny because you guys are scared of 0. All right. And by funny, I mean like I needed you to make sure you weren't scared of 0. Do we want to see these two? Anybody? Dominator? Okay. It is crazy. This one, you want to distribute? Okay, let's do it. 30. Yeah, you will distribute in this one, right? Because it says timesing. Are we cool with that? Everybody freaks out about this one because they don't know that they can times from behind. You can. It will be 3x squared. Nobody ever remembers the square. Stop forgetting the square. 3 times x is not 3x. It's 3x squared. Ember, what is 3x times y? Thank you. Is 3x times negative 2z going to come out positive or negative? Negative 6xz, right? Dunzo. Can't combine them any more than that. Okay. Fam, are we distributing down here? Because we just got done distributing and now we're like in a mood. No. We're subtracting. You guys are really bad at minusing. X minus 5x. How many x's? Negative 4 x's. 7 minus negative 4y. 7y minus negative 4y. Guys, you know what minusing a regular 4 does? It sends it down, right? Is this a regular 4? No, so it must send it up. We're at 7y and we're going up 4y. Where are we at? 11y. You did it. Watch out for double negatives. Factor. Is factoring the same thing as division? They're pretty freaking similar, but they're not the same. If you divide everything by 6 here and write x or negative x plus 4y, this is wrong. You change the problem. Is this an equation? No, so you can't divide everything. It doesn't work that way. You change what it's expressing. However, if you factor out a 6, do you see how this still is the same thing as this after you distribute? Yep. Factoring. Yay. Factoring is super important. Algebra 2 is like factoring the class. This is baby factoring. But yes. Fam, how many copies of this do we need to get this? 4 copies. Good. Why can't we just add these? They need common denominators. So, will this ever be a y? No, so we have to give it a y. Can I just times by y? Does that work? No. Timesing by y changes the problem. Is this an equation? What are we going to times by? What is y over y? Does timesing by 1 change anything? So do I have to do it over here as well, times y by y? No, I need x by x over here, which is legal because they're both equal to 1. It doesn't change anything. It just gives us new perspective. And perspective is everything. Rule number 4. Yeah, it turns out all of those are really good and important, and you should actually understand them. See how they both have the same denominator now? I sure hope it does. That was the whole point. I'm going to blow somebody's mind right now. When you write these all on top. Okay. If you write them all on top, it's 1 fraction, and now we're done. The thing I'm going to blow your mind with, though, is that division distributes. Multiplication distributes, right? But so is division. See how it says divide these two terms? Going in reverse is like distributing the xy. Do you see it? Distribute the xy. That's pretty sick, huh? Division and multiplication are the same thing, so it makes sense they work the same way. All right, how we feel about that? Why is y up here? Here. Here. Negative, I left the x off. You should be asking why the x wasn't there. Negative 5x plus 3y is this. Better? Yes. We got to bring the green screen in so I can get the... All right. We want to get x in terms of a, b, and c. That means we want to get x equals a bunch of stuff with a, b, and c in it. X has to be completely on its own, and it has to equal stuff with a, b, and c. If you have 2 x's, that doesn't make any sense, okay? It has to be x on its own equals a, b, and c. Yes? Jackson? What are we going to do? I mean, you can. Yeah, that's totally fine. If you times everything by a, that divides out, right? But you have to do it to every term. So you're going to get here. That works. And now how do I get x on its own? Why would I subtract x? That's going to make it negative. I want regular x. I would add ab. That's the quickest method, right? You could have added b first and then times everything by a. That works too. It doesn't matter. I like that Jackson knows he can times first if he wants to. That's good. No rules. No rules. Just understanding. All right, same equation, except now we're getting b on its own. Notice I want positive b. So what if I just get b to be positive first? How would I do that? Add b to both sides. Now how do I get b on its own? Subtract c. This class is impossible. No one can pass it. It's so hard. Can you imagine how easy this would be if you had, like, I don't know, 42 minutes, 5 days a week for 16 weeks to learn this? This would be literally a joke, right? You guys are learning this, quote unquote. Understanding takes time. You're running out of time, so you're not really learning. You're just kind of being told it. But hopefully you'll learn it. Because hopefully some of this will be a review. But if you had 42 minutes, 5 days a week for 16 weeks, this would be so easy you'd be bored with this class. But you didn't do that, and that's why you're like, ah! Chloe Majors says she is bored with this class. Earlier she was freaking out. She was so mad at me. For the record. For the record. Fam, we're on the intermediates. What? Yeah, you don't know the lore. Yeah. Well, he's going to listen to the video and learn about that person. Her name was Jeanette. And then he's going to learn about which one had the testicular cancer. I don't remember which name it was. I just remember we used to call him 1 ball and 2 ball. I think Aaron had the 1 and Ethan had the 2. I might be mixing that up. Yes, it's true. All these are true. A long time ago in a galaxy far, far away. I'm like at least 105. All right, so if x is 5 and y is negative 2, let's just plug stuff in. You have to do this. I know some of you guys use a calculator because I can tell when you guys get this answer wrong, it's because you're using a calculator and you didn't use parentheses. If you don't use parentheses, you would write negative 2 squared. Now, fam, this and this are not the same. This means 2 squared, but I want the negative version. What is that? Very good. This means I want to times negative 2 by itself twice, which is positive 4. Now, why is that? Emma always asks this question. Why is this going to come out negative? Here's why. We're trying to be consistent. If I write 2, what does that mean? 2. If I write negative 2, it means I want the negative version of 2. Negative 2. So if I do this, it means I want the negative version of 4. Right? This is saying take all of this and times it by itself. There's a difference, right? That'll come out to positive 4. This would come out to negative 4 because it says I want the negative version, right? Cool. X is 5. 5 plus 3 is 8. 4 over 8. Just for funsies, what common factor do they have?
4.
What's the biggest common factor? 4. We can write as 2 times 4 and 1 times 4. 4's divide out to 1s, and we get a half. Yes, that is how you simplify fractions, but no one made you do it, and that's why you guys suck at dividing. All right. Y to the x. We said y is negative 2. And we said x is 5. Fam, what does it mean to take it to the 5th power? Good. So is this going to come out negative or positive? Because it's an odd number, but yeah, words are hard. Do you guys see how it started negative? If I times it by a negative, it's positive. Now it's negative. Now it's positive. Now it's negative. She loves me not. She loves me not. She loves me. It's negative, right? So this is negative something. What's 2 times 2?
4.
Times 2? Thank you for not saying 6. Times 2? 32. No. I could do it if you guys didn't require me to go so slow. But I am being required to go slowly. And that's fine. I can review 5 chapters in 3 hours. I can't teach it in 3 hours. And this isn't really even teaching, because understanding takes time. Yelling at you guys doesn't work. Although it can work better when you guys are like, I'm going to lock in. Thank you, but no. That's very nice of you. For the record, Jackson Booskel's okay. Like, despite what everybody says, like, I don't know why everybody's like so mean to him. Like, they're always saying all these things, and I'm like, he's not that bad. Like, I get like some of it, but like not all of it. You know what I mean? He's not that bad. All right. Anyway, fam, do not be afraid of using multiple parentheses. Do it. You won't make mistakes. My math teacher in high school, who I later went and subbed for her for calculus without a degree, mind you, who wouldn't let me into the advanced classes, I never made any mistakes because I used lots of parentheses, but she made fun of me. But at the end of the day, I didn't make mistakes, and she did. So there you go. Did you guys get the joke? She was pregnant. She made mistakes. Okay, anyway. So this right here. Always wrap it in parentheses. Anyway. You got that one. Okay, cool. It prevents a lot of little mistakes. What's 3 times negative 2? I should tell you the story about my health teacher sometime. It was crazy. Oh my God. Absolutely insane. When your old babysitter is your health teacher. Crazy. Yeah, she was like, don't go to the basement. We're doing construction. They were doing construction. Negative 6. And then she was my health teacher. And I'm like, that is strange. Yep. That was a fun one to explain to my mom. Your son went to the basement because he needed lemonade, and I said, don't go to the basement. I didn't see anything, but my mom thought I did, so it was very funny. All right, anyway, here we go. Shout out to Terry. Anyway. This is negative 11 minus 1. Negative 1, it multiplies to 11. Yeah, crazy. You know one of the things she told us in health class? We were asking to turn the lights off to watch one of the movies that she was showing us. And she said, we're not turning the lights off. And we were like, why? And she's like, if you can't do it with the lights on, you shouldn't do it at all. For real? Well, this was like 1998 or something. So this is pre-Kanye, but yeah. I don't remember. It wasn't 1998. It was definitely after that, but yeah. Okay. Guys, do you see how I'm plugging all this stuff in? A is 2/3, B is negative 1. B is negative 1, and C is 9. Stop freaking out. This is not that bad. This is actually really easy. I know. I wasn't talking to you, okay? I was talking to the person inside Ember's head right now. It's a twin thing. You wouldn't understand. All right, so, fam. Do you see how we can times or divide first? Let's divide. What's 9 divided by 3? So what's 3 times 2? Does it make sense that 2/3 of 9 is 6? It does, doesn't it? 2/3 is 6, right? 1/3 is 3. This becomes negative 2/3. I'm going to write it with a plus sign there because I didn't earlier and it freaked people out. I don't know why. And then this becomes minus 9. I do my own thing. I'm not writing a plus sign that time. Suck it. All right. Moving on. So we need common denominators. How do I get common denomies? I can't times by 3. This is not an equation. What? Yep, which means we didn't change the problem. We get 18 over 3 minus 2 over 3 minus 27 over 3. No. Isn't this 29, negative 29? They're all thirds. Isn't this negative 29? If I add 18, I get negative 11. Negative 11 thirds. Next one's even easier. Did you know the square only applies to the b? The square only applies to the b. What's negative 1 squared? What's negative 1 squared? The 1. So we get 1 times 9, which is 9, right? If only we knew what 2/3 times 9 is. It's 6. 3's divide out, and you get 6. Okay. Well. Are we ready for the next page? Oh boy. Are these equations? Then why do you keep multiplying by 3 to everything? It doesn't work. You're making everything 3 times bigger. That's not the same thing anymore. If it was equaling something, then they'd both be 3 times bigger, and that's fine. But this doesn't equal anything, so you can't do that. So we need to get common denomies. Why are you trying to get these to be common denomies? You can already add them together. How many c squareds? He was thinking c squared and c squared because he remembered a trick or something that you do with exponents that is totally not screwing up his life right now that I told him not to do. All right, cool. Anyway, these are going to go together, though. Notice that I can never combine these with this because they're just different variables, right? Stop trying to make it happen. It's not going to happen. So we need commie denomies. How do I make this have 3 on the bottom? Nope. Times it by 3 over 3. That would have changed the problem if I divided by 3. What is 3 over 3? 1 doesn't change anything. So what do we end up with? We end up with d squared over 3 minus 12 over 3 d squareds. Do you see how 4 is the same thing as 12 divided by 3? I didn't actually change the problem. I just made it look different. It's a change in perspective, rule number 4. This becomes negative 11 thirds d squared. Here's why. This just means 1 d squared. That was awesome. This just means 1 d squared. What's 1 minus 12? Negative 11 thirds d squared. You can write the d squared on the top, or you can write it on the side. It doesn't matter. It really does not matter. And then we have to add 9c to that, or 9c squared. That's never going to come together, so that's as simple as it gets. Part B. We got to get commie denomies. This is actually pretty easy on this one. What are we going to times by? 3 over 3. And now we get this. I'm going to cut to the chase here. Aren't they all going to be divided by 3c? Okay, cool. So they're all going to have 3c. It's going to be all over 3c, right? This is 6a. This is now 3a. Are you seeing that? This is 5. This is 3a minus 8. And now we just combine them all and simplify. Looks like a total of 9 a's. Oh, nope, 12 a's. My bad. And then we have minus 3. 5 minus 8, right? What do you notice? What do you notice? What do you notice? Yes, we can take out a factor of 3 from everything. We get 4a minus 1. And now, because it's timesing, we don't have multiple terms, right? We can divide 3's out safely. And we get 4a minus 1 all over 1 times c. That's just c. That's simplified. All right. Do we want to do these two? Yes or no? Anybody want to see them? Dominator? They said no. Say no, or say yes if you want to do these. Okay. What does it mean to take it to the 4th power? So we're going to do x cubed times x cubed times x cubed times x cubed. How many x's will that be? X to the 12th, right? 3 of them, 3 of them, 3 of them, 3 of them. We're going to do y to the 4th times y to the 4th times y to the 4th times y to the 4th. That's y to the... And they're still being multiplied, so there you go. No add sign. Why do you guys just add random add signs? There we go. Fam, if we're cubing, what does that mean? Thank you. So if we cube z cubed, that's going to be z to the 9th, because z cubed times z cubed times z cubed is z to the 9th. V to the 4th times v to the 4th times v to the 4th is v to the 12th. What's negative 2 times negative 2 times negative 2? This comes out negative, right? 2, 4, 8. Yeah, odd number of negatives. Yeah. Say yes if you want to see these.
Yes.
Good. 18 and 27 share a common factor. What factor do 18 and 27 share? They share 9. They also share 3, but 9's the best one. 9 times 2, a squared, b cubed. And 9 times 3, a to the 5th, b to the 4th. You smell what I'm stepping in. The 9's divide out, don't they? And this becomes 2/3. 18 over 27 is the same thing as 2/3. Now, all of the a's are going to divide out except for how many? Where are they going to be located? 3 on the bottom. So a cubed is on the bottom. All of the b's divide out except for 1 on the bottom. So we get this. How you feel? Negative 3 and negative 9 share what common factor? Negative 3. So negative 3 divides out, we get 1. Negative 3 divides out here, and we get 3. 3 in the bottom, 1 in top. I'm not going to put the 1 in top. Do you know why? Timesing by 1 doesn't change anything, so why put that there, right? X squared divided by x squared, what's that? 1, so it goes away, right? Y to the 7th divided by y to the 5th, there's going to be 2 y's left over on top. Z over z to the 4th simplifies to. All the z's divide out, so this becomes a 1, but all of these we get z to the 3rd, right? What? Oh, yeah, I'm talking about the z's. Yeah. 3 on the bottom. Location, location, location. That's probably a bad idea. What? Oh, these guys? I drank that earlier today. Like 3. These 3 different things? I'm not out, no. Okay. Do you want to do this one? What if it was t cubed, though? Would you want to do that? Fam, what do we need to times this by to get this? 8, definitely. What else? Are you smelling what I'm stepping in? I am. I changed it to a 3 to make it more interesting, Ember. I asked the questions. What's the one you got? All right. Fam, are these the same? No. So you have to distribute the 3, and you have to distribute the -5, and you put them all together. I'm going to do that real quick because it's boring, and then I'm going to show you a cooler thing that happens if they were the same. So if I distribute the 3, we're here. Is everybody cool with that? -5 to everything. Yes, it is -5. That gets you -5t squared, -20 ts, and -5s squared. Now we combine like terms. How many s squareds will that be? -2s squareds. There's no equal sign here. How many t squareds are there going to be? -2t squareds. How many ts's will there be? Girl. Negative what? Thank you. That's as simple as you can get it. You can't combine t squareds with ts's. You can't provide s squareds with ts's. Now, can I show you something else? What if this were the problem instead? Do you see what I changed? Now is this the same as that? I have 3 of them. I'm taking away 5 of them. That would end up with -2 of them, wouldn't it? And now you can distribute that 2, and it's much easier, right? Now, this only works if they're the same. That's kind of like saying let x be this crap and let x be that crap. 3x's minus 5x's is -2x's, right? They weren't the same, so you couldn't do it, though. Sorry. But if you can, that's a lot quicker. Distribute the -2 and you're done. 433. Yes, sir. Do I have any yeses? What common factor? They definitely share a 4. What else? You can take out 1x and 1y. So we're going to be left with 4x squared. Because if you multiply these back, you get back to this, right? Minus 1, right? Do you guys see how if I were to distribute back, I'd get to this and this? That's how you check it. Is there anything else I can take out from these two? No, there's no common factors left, right? 4 and 1 don't share any factors. X squared and no x squareds don't share any factors. Down here, we can take out a 7r from everything. That's the most we can do. We'll be left with r squared t squared minus r squared t plus 1. I'm going to pause so everybody sees this. If I take out a 7 from this, there's no 7s left. If I take out an r from this, there's only 2 r's left. And 2 t's, right? If I take out a 7 from this, there's a -1 left. If I take out an r from this, there's r squared and a t. If I take out 7r from this, there's 1 left over, right? 1 times this to distribute back. Okay. All right. What common factor do all three of these share? They definitely share 3. That's the most you can do. A and a C. Can we take out a B from everything? No. So we're left with negative 6a cubed c to the 4th plus 3a c to the 4th minus b. You can check that. If you distribute, you get negative 3abc. Good. You get 9a squared c to the 5th. Love it. And you get negative 18 a to the 4th c to the 5th. Love it. You get 1. But it's a double period, yeah. So you get 180, or you get 84 minutes or something like that. I don't know. Yeah. Americans. All right. Fam, why can't we just minus them? What do we need? Tommy denomies, that's right, Dominator. You could times by 10x squared over 10x squared and 5x over 5x. However, what if I just times by 2x over 2x on this side? Or on this, for this term? That'll get us 10x squared in the bottom, won't it? Cool. Is this an equation? No, so I shouldn't see people trying to times to get rid of the divisors. You can't do that. You have to times by 1 without changing things. So we get 3y over 10x squared minus, we'll distribute 14x minus 2xy. Do you see how that's 2 terms, so we have to distribute? 2x to the 7, 2x to the negative y. Now, be careful when you put these together. Danger, warning, danger. We're subtracting, right? We're subtracting. So we got 3y minus 14x's. Everybody gets that one. Why is it plus 2xy? Mars sees it too. Minusing 14x is this. Since this is 2 terms, we minus everything. Minusing this is really adding, isn't it? So this says minus this, right? See how there's 2 terms? Minus 14x minus negative 2xy. Better? Yes, it is. The reason you're getting this, Chloe, is because you have the skills to pay the bills. You had it, it was there, and we made it past the phase, and now you're in the I can grow phase. I'm very happy for you. All right. No, thank you. Why is this one a intermediate question? We already did this. A's in the denominator. That's hard to deal with. So what if we just get A out of the denominator, and then it will be an easy question? How can we get A out of the denominator? It's an equation, so we can times by 8 everything, right? Yeah. I'm cracking my voice like Colton Wright. Crazy. A divided by A is 1. Oboe boy. To every term. Fam, what are we trying to get on its own? A. We're going to get everything with A on one side. You cannot, hey, stop. If you divide by C, that gets A on its own here. But will that be A in terms of X, B, and C? No, it'll have another A over here. You can't do that, okay? So you got to get all your A's together. And I'm going to do that by adding that over. Now, here's the big brain play. This is the thing that you need to know. It's not as simple as, oh, when I times, I divide. When I subtract, I add. Here is where things get interesting. A's in 2 spots. There's no way you can divide, multiply, add, or subtract to get rid of that to make one A. What are we going to do? Nope. Dividing, multiply, adding, subtract will not work. If you divide, you're going to get A in the bottom here, and we're back where we began. Can't combine them. They're not like terms. I mean, technically, yes, but you're also wrong. Now that they're all on the same side, what common factor do they share? So we can factor it out. Do you see now A's in 1 spot? That is big brain, big brain. Fam, we now have A times something equals X. If this was A times 5, wouldn't you divide by 5? Wouldn't you divide by 5? So we're not going to divide by 5. We're going to divide by C plus B. And that's going to get us this.
If we write x equals a plus
You have to divide by C plus B to get A on its own. That's the only way to do it. You have to factor. That's the big brain play. The further we get in math, the more it's going to be you need to understand what tools you have in your tool belt, and you got to know when to use them. It's not a matter of minus means plus. Okay, that's all the intermediates. Spicy, yes or no?
I think I'm good.
Okay,
No.
436.
okay, check it out. How many terms do you see? So that would be 2. Very good. What common factors do they share? We'll take out a 2x. So check this out. I'm going to use giant parentheses just so you can keep it organized, okay? And I'm going to use brackets. So that means we're left with y plus 1 minus 2x times y plus 1, right? It says factor as completely as you can. What common factor do these two share? That's a term, that's a term. Here's 1, here's 2. What common factor do they share? Y plus 1. So we can also take out a factor of y plus 1. Are you ready for this? 1 minus 2x. And now it's fully factored because this doesn't have anything else. Do you see how I took out a y plus 1 from both? And I'm left with 1 after I take that out and negative 2x. It is spicy. If you really understand your stuff, you're going to be able to follow that. If you don't, then it's going to be a lost cause. Any others you want to see? Yes? Easy. All right, we're going to do this one because Christina's requested it. See how we have 2 terms here? What if we didn't? What would we do with the 8? Cool. Let's say the 8 wasn't there. What would we do with the x? Cool, so we're going to do both. X to both terms. X, y, minus 3x. Are you smelling what I'm stepping in? Now we got to distribute 8 to everything. 8y minus 24. Hey, look, you did it. Advanced doesn't mean hard. Any others we want to talk about? Okay. You have to factor for this one down here as well, by the way, if you're interested. To get x's all together. Get it? Yeah. I mean, do we want to see these or not? I thought I was just doing this for Christina. Okay. All right. That's it for 4 then, huh? Dom, never mind. I don't want to answer that question. Look at his mouth. All right. It's blue. Are we doing 1, 2, or 3? Okay, 3. I'm going to use the bathroom, and then we'll be at the 3. Yes. Okay. No. Instead? Maybe 6. Where? And where? Wait, where's the variance? Where's this problem? Where do you see it? No.
I had no grip on the ball.
This ain't your pop.
No, okay, maybe not.
Where is it?
You threw it so hard. It didn't pop, but you threw it like as fast as you could smack it against the ground.
Well, because we're trying to play catch. We're trying to play catch.
It didn't pop.
There's just so much there.
Jackson. Jackson. No. No. What?
Did anyone leave our class?
Max, I know.
What you said? What you said? It's falling. It's
No,
actually
no.
kind of.
You figure out how hard it is or what?
No, that's like nobody even have like vegetables. There's no like canola. I don't understand. It's like very.
That's just like flash hard on Little Lock. Little Lock. You may identify by Indiana?
It's Matthew Banal.
No. For 30 minutes before that. Hey, Jackson.
Stevenson dropped a pan on Miss Molly's first foot. How did she do that?
Who is Miss
We
Mullen?
were taking out an ad, and Carly like dropped a pen that we were grabbing from the class.
I know. Hello.
That might be the fastest I've seen.
Oh, because he was ding dong dishing us. That's why. Oh, never mind. All right, quiz 3 is going to feel really easy. It's just equations with one variable. Yes, absolutely. Are these equations? Yes, so we can multiply by anything we want, so we can get rid of denominators. That's nice. That's nice. Okay. Part C, Part D. That's what I got the request for. Did anybody want to see A or B?
Wait.
I want yeses, not nos, okay? I don't want people saying no, because then other people will be like, I don't want to say yes because I want to be dumb. But here's the secret. You're all dumb.
You want to see the basic question. You want to see
Hey, speak no evil.
Thank you. All right. Yeah, don't do that, okay? Because you were dumb. You're dumb too, okay? You really are. You really are. There was no one in here that is like too smart for this class. The heat is off because it's after school. I don't control these things. Talk to the superintendent. All right. So, A or B, yes or no? A, I need a yes. Anyone want it? I need yes, no nos.
No. Yes.
I-
If you want yeses.
28.
Thanks.
B, don't say anything if you don't want it. Say yes if you do.
Amber, you ruined it.
If nobody says anything, I can just do it really fast then. All right, C. We want this? Yes? Okay.
C.
What can we multiply by to get rid of fractions? Fractions are decimals, right? That's true. Some decimals are not fractions. That's true. Like decimals that go on forever, like pi.
I can sing to the hundred. Oh,
You can.
yeah.
You would. Just to be clear, that doesn't mean you're good at math or bad at math if you like that stuff, but that fits with your personality. And I'm telling you, you have the personality to be really good at math. I have always believed in you, Chloe Majors. So if you're hearing this while you're about to fall asleep, I always believed in you. Fam,
Wait, how did you get from? How did you?
fam, what do you add to -6 to get 7? So what do we know?
13 over 2.
So it's 13 over 2. Yeah, really good. You know why 6.5 is a stupid answer? Imagine that wasn't a 2. Imagine that was a 7. Okay, give me the decimal now. It's 13 over 7. I win.
What's the answer?
This one, because it was this.
They're both certain.
No, they're not. Dom's checking out the board game collection.
I was thinking about running
Here's the thing with Skull Bowl. You have to be okay with getting your teeth kicked in because every other school is better than us.
last one
Oh, the one with Cody?
No, I had one.
Yeah, okay. Yeah,
You got one question right, and it was the one for like pizza.
yeah, exactly. Yeah. We are getting better, but part of it is as soon as we get good people, they graduate.
Yeah, but then like the other team like knows everything.
Yeah, so if you're okay with getting your teeth kicked in like 3 years from now, like destroying everyone, then sign up.
Why is the board broken?
Harper. What can we times by to get rid of fractions?
4.
4 divided by 4 becomes 1. What's 1 times 1?
Swan.
That was not funny.
Oh my god, you're all dumb. Fam, what do you add to 3 to get negative 7?
-10.
So what do we know?
4x, yeah, so it's 10 over -4. Is it?
It doesn't matter where the negative goes. Yeah, negative 5 over 2. Yeah, whatever. All right, we cool? All right. Ember, you were too busy making your mom jokes. Let's go. That was recorded. I like that laugh. Bro. What does it feel like to have no original personality of your own, but only TikTok? How is that? How's that going? Like every word out of your mouth is not your own. It's just like a thing from TikTok. That's crazy. That's a negative 10 over 4. Open your eyes.
Okay, that was one.
4.
Yep. X is 4. All right, decimal boy. This one you could do, but I won't make you use a decimal. What's the answer going to be?
Oh my goodness, I was gonna say.
It's negative 0.8, but like, who cares? All right, are you ready for a really big brain play here? 3 halves. Do you know how I know it? 3 halves. No, chill. Just chill. No. What do you divide by 4 to get this? 3 halves divided by 4 is this. Divide by 2 and divide by 4, right? I'm already dividing by 2, right? See, here's what y is, and I'm dividing by 4. That's the same thing as this. 3 halves divided by 4 gets you 3/8. Now, if you don't see that, this is an equation, right? So we can times everything by 4. Do not times by 4 over 4 here. That won't do you any good. We get y equals 3 times 4 divided by 8. You can do 4 divided by 8 first. This becomes a 2, this becomes a 1, right? 3 halves. Four divided by 8 is not a 2 here. It's a half, right? 4 divided by 8 is a half. So it's 1 over 2. Common factor of 4 divides out. Or you can think, what divided by 4 gets you 3/8? This divided by 4 gets you 3/8. Pretty sick. Okay. Using our newfound power, S is going to equal 2 times 9. Do you know how I know it? If I put a 9 here, what happens? 9s divide out. That's pretty sick, right? Yes. I'm going to show you another way to do it, though, because a lot of you guys are going to be confused by that. What if I times everything by 9? 9s divide out. That's why I did it. I get negative 4s equals negative 72. So the answer is S equals negative 72 over negative 4. That's going to be equal to 18. All right, Christina, what's your question? Negative 8 divides out. In parentheses? Quiet, everybody. Stop tapping your feet. I got to understand her. What are you saying? Okay, sticker. Oh, you want me to put a sticker down so you can show me?
No. Like, for I do photo and I may see all that. Like,
Oh, you want both for the photo?
Yeah.
For the photo. Yeah, okay, I understand.
thank you.
You're welcome. Should have just said flick. I would have known. All right. How do we feel about timesing everything by 9 and dividing everything by negative 4? This is pretty slick, though, right? I mean, it's some big brain play there. That's some nice stuff. Okay, fam, you could times everything by 5. However, x is all in one spot. So what do you divide by 5, get 3? So what do you know? X minus 2 must be 15, which means x is 17. We could distribute the 6. However, this is all, if we treat it like one idea, what's 6 times what gets you 36? So what do we know? Which means r is... What do you take away 9 from to get 16? So how do I make that 25? X is 5. All right, how do I write 6 times a number? Sure, 6n, 6x. I'll use 6n. And they're telling us 8 more than double the number. Forget about 8 more. We'll deal with that later. It's 8 more than what? Double the number. How do I write double the number? Is this what they're saying? No, which one's bigger? Be careful. If n's negative, this would be less than, but it says it's more, right? So if this one's bigger, what are we going to add 8 to make it equal? Now the little one is the same as the big one. This is 4n equals 8, which means n is 2. God, you should have seen the one in the bathroom. Oh, man. What if we take 2 erasers and we like... No. She already did it earlier and it wasn't funny. No, because you couldn't hear the thing. She's going the entire time. Sure you were. We have it on video. All right.
Yeah, go watch it.
Are we doing this or not?
Yes, we are. No, we're not. Wait.
Do you know why it's intermediate? Because the variables aren't all in one spot. So if you got the variables all in one spot, you instantly win. Got to be a negative number. What negative number? It's got to be a negative number.
-3.
Yes, so 9r is negative 13. There you go, decimal boy.
Where are you getting 9R?
18 minus 5 is 13.
6 plus 3 is 9.
Hey,
-3R?
as the person that has the most dumb questions, you should not be insulting her.
Okay, yeah. We didn't even talk, first of all. We're negative, never mind. -3R. -3R?
Add it over. It's okay. You got to ask those questions because you're gonna be stuck for minutes, right? And you should just ask it, and then you can be good, right? So there we go. How do we make this easier to work with?
Multiply by. Oh yeah.
Yes, number's big, but at least not decimals. All right, here you go, Ember. I'll zoom out a little bit. So if we get our y's together, we get 9y and 50, and this equals negative 360. If you want to, you can subtract the 50 over, but honestly, it's not going to make it that much easier. But I'll do it. I did, perchance.
How was it 9 y? I haven't said that's what we did it before.
Did I goof? Minus 16 is 9y, right? Yeah.
How was it minus?
I subtracted it over the equal sign.
Oh my.
Don't feel bad. It's okay. You should ask small questions like that, just like she did. That way you can get the answer and be okay. If you don't ask, you're going to be confused for something stupid for 10 minutes. All right. Or never figured out, which is worse. Do we see why this is the answer? Cool. Yeah. There's new stuff. Oh, yeah, there's a new thing every day. Yeah.
Mr. Math, what is the I have like nothing but the E stand?
Fraud.
She was bad at spelling because she had dyslexia. She still does. So, Zoe Wyatt. So she spells things wrong, and she gave me that. I helped the economy was because we helped the economy during COVID, even though people were dying. She thought it was funny. Okay. The hair.
She do it like
Oh, the frog is crazy. That's done by Kirsten Romero, who is like her best friend. Have you guys found the spoon yet?
it's not in. Mr. Math, can we just like draw through this? Please let me do your thing now.
I keep anything you give me pretty much forever. I have boxes of it in my basement. When I die, I'm bequeathing it to all of you. What? I just made your sister's face. Yeah. Constantly last year. That's the difference between you two. All right. She's terrified of being cringe. You're just like, no big deal. It's on page 5. Yeah, you don't care about being cringe. Who is happier? You. Fam, is this an equation? So we can times to get rid of fractions. What's going to be the best number to multiply by? 8. 8's divide out, you get 1. 8's divide out, you get 2. Are you seeing it? Yeah.
Okay, guys.
Oh, that's so sad. Okay. 8's divide out, and we get 2. 8's divide out, we get 1, right? Is that cool? 2 times 3 is 6. If we get our variables together, this will be really easy. 6 equals 9t minus 48. What do you take 48 away from to get 6? 50. 54. So what do we know? Which means t equals 6.
I'm not even talking to you anyways.
We're going to simplify this one first. Do you see how these are both on the same side? Oh, whoops. Yeah, you're right. Negative 7. I'm going to rearrange this to make it easier to see. What do you notice? You have something minus 9 and it equals the same thing plus 16. How can you have something, take away 9, be the same thing as something plus 16? No solution. Let me show you what would happen if you tried to get your variables together. It just so happens they both go away. You get negative 9 equals 16. Is that ever going to be true? No, you could never make that true. Cool. All right, down here, let's rearrange this. Do you notice we have some numbers over here we can put together? All right, now you got to be careful. This is not no solution. What can you take away from 9? That'll be the same as taking away from 9. This is a tough one. If y was 1, we get 9 minus 22, 9 minus 170. Is that the same? No. Okay, I lost her. If y was 1, we get 9 minus 22 and 9 minus 170. Does that work? No. What if this was 2 and 2? No. What if it was 3 and 3? No. There's only one number that works. Yep. 9 minus nothing equals 9 minus nothing, right? 0 times 22? 0. Now, fam, here's what would happen if you got your y's together. Or actually, let's subtract 9 from both sides. These go away. And we get negative 22y equals negative 170y. Clearly, the answer is 0. That's the only thing that works. But if you're still not sure, add 22y to this side, and you get 0 equals negative 170y. and 48y's. Hopefully at this point you see the only way to make this equal 0 is 0, right? If you don't, divide everything by negative 148. Well, then you get this, right? Because 0 divided by anything is 0. But yeah, y is 0. Y is 0. It's the only way to make it work. Sorry. You want to see this one? Yes or no? Ellie said the answer to this was 8. Why is this a really bad answer? Think about it. If I plug in 8 here, I'm going to get 8/3 plus 21. That's going to be a fraction, right? Will this equal a fraction when I plug in 8? No, it'll be 40 minus 9. It's 31, right? So how can a regular number equal a fraction? Terrible guess. If she guessed 9, that'd be okay, because this would come out to a whole number, and so would this, right? If you did 3, that'd be okay. 6 would be okay. 12 would be okay, but 8's not, and that's why, okay? No, she made a mistake, but she wasn't using her brain. All right. She then shakes her head and starts over, so she must have actually used her brain afterwards. My brother is 6 times as old as I am. Here's my brother's age. Here's my age. Is this what they're saying?
No.
Who's older?
Brother.
The brother is older. How much older? 6 times older. So how do I make me match him? Or divide that by 6, but yeah, same thing. 12 years from now, here's the catch. Is this how old your brother is 12 years from now? B plus 12 is how old he is 12 years from now. I'm also 12 years older 12 years from now, right? Who's older? Well, always the brother, right? Right. However, he's not 6 times as old as me. Now he's how much older than me? 3 times as old. You better, no, not 3M. That means 3 times my age now plus 12. You want 3 times my age now, 12 years from now, right? So there's a big difference. This is elimination, substitution. What are we going to use? Substitution. Do you see how B is equal to 6M? Do you see how B is equal to 6M? That means wherever we see a B, we can replace it with 6M, right? This is sub. This is sub. I'm going to distribute that 3. After getting our M's together, we get 3M plus 12 equals 36. Fam, what do you add to 12 to get to 36? So what do we know? 3M is 24, and M is 8. Good, we found the thing they wanted, right? Oh no, what do we want to find? So if I'm 8 right now, how old is my brother? 48. Age gap. Guess what? This question is an English language learner's nightmare. So thank our English language learner for not having to do it. No. Nickels and dimes? Yeah, because this is an English language learner's nightmare. I also don't like it because it's just really wordy and it's unnecessary.
So we're not going to do one
No. Belt. Fam, do we want to do the nickels and dimes one or no? This is the we want to know how many nickels there are, right? So N should be the number of nickels. Do not make it the value of nickels. You know the value of a nickel. What's the value of nickel? Yes. I would like to point out that you could do this during first hour and you would learn a lot more. You guys actually pay attention and interact. What do you know? D should then be the number of dimes, right? Okay, is this true based on what it says in the problem? Does she have more nickels or dimes? She has more dimes. So there's more dimes. How many more dimes? So what do we need to do to make them equal? Thank you. She also has a certain amount of money in her piggy bank. It's $26.50. That's in dollars. Now, is the number of coins going to add up to the amount of money? No, that's not it, right? We're not doing pennies here. So what we need to do is figure out the value of the nickels plus the value of the dimes to get the value of the piggy bank. How do we get the value of the nickels? Yeah, if you take the number of nickels and times it by its value, don't you get the value? And it needs to be 0.05 because it's $0.05. This is dollars, right? And dimes are worth $0.10. This will turn into how much money we have in nickels, right? If I had 10 nickels, I have 50 cents. If I have 10 dimes, I have $1, right? Cool. We can make this equation easier to work with. How? Yeah, you could do that. That's fine. So D is the same thing as 2n. So we end up with this. Why is that a good move? Ding, ding, ding. This becomes 0.05n plus 0.20n equals 2650. Altogether, that equals 0.25n. How can we make this easier to work with? You could, or you could think, how many nickels are in 2650? Well, they're nickels, but yes, I know what you mean. So here's what we're going to do. We're going to times by 100, and we get 25n equals 2650. So what times 25 gets you 2650? Isn't 10 times 25? Isn't 100 times 25 250? 150 left over, right? So it's 106. I'll do it again. 100 times 25 is 250. 6 times 25 is 150. Right? So 2500 and 150. If you say so. Yeah, because double, right? Yeah. Are we doing the Wyatt problem or no? Are we or not? Wyatt was asked by her teacher, I gender change here, it's fine. Asked by her teacher to subtract 7 from a certain number. That's this. And divide by 14. Instead, what did he do? He subtracted 14 and divided by 7, getting 56. I change the names, and sometimes I forget to change the pronouns. It happens, okay? It's totally fine. Maybe he's gender fluid, or she. All right. I did have a girl Wyatt, right? So, fam. So this is what he was supposed to do, and this is what he actually did. If we knew what n was, couldn't we do the right thing? That's what we want to figure out. How can we figure out what n is? That's what you meant. So n minus 14 obviously equals 56 times 7. What's 50 times 7? What's 6 times 7? 42. 350 and 42 is 392. So n has to equal what? So now if we do the right thing, we're going to get this. 399 over 14. Are we okay? Everybody that watches the video is going to be like, this is too fast, but this is the speed they're ready for. That's what they keep saying. Are we okay? Hey, last page of the intermediates. Is this an equation?
Yes,
It is. So what can we do to get everything to work? What's the smallest expression that is divisible by 5 and by x? 5x. Let's times everything by 5x. Now, some of this will divide out, some of it won't. X divided by x divides out, and we get 20. Are you seeing it? X's divide out, and we get 20, yes? 5's divide out, and we get negative 6x. X's divide out, and we get positive 10. 5's divide out, and we get 2x. Doesn't this look like an easy problem now? Looks like we have 30 equals 8x. So what's x got to equal? Yep, 8's divide out, you get 30. 15 over 4 if you want. I don't care. Feeling good? All right, Jackson's favorite problem. You could do that. I think it's a little overkill. So I think it's good to know that you can just add these, right? So this becomes 5, and this goes away. If I have, so let's use Jackson's idea for a second. Pretend that x is this thing, right? This is just x. So I have x plus x. What would I write? X plus x is 2x. But it's not really x. It's 2 times the root of 3r. Okay, so what do you take away 13 from to get 5? Finish your answer. Well, do you see how this is one thing? It's 18, right? 18 minus 13 is 5. So what do we know? What do we know? Positive. 18 minus 13 is 5. What do we know now? The root of 3r must equal what? Are you seeing that? Because 2 times 9 is this. Right? 2 times this thing is 18, so this thing better be 9, right? What do you root to get 9? Do not say 3. This must be 81. Think about it, right? If the thing inside of here is 81, we get 9, right? So that means 3r must be 81. 81 times 3 is what we... what do you times by 3 to get 81? 27. And that's all of the intermediates for section or chapter 3. We've done 3, 4, and 5. We didn't do 1 and 2. 1 and 2 were on the other video the other night, so you can watch that, or we can do it again later. What? Yeah, it's fine. That's fine. Yes. Yeah. The pens? Yeah. No, she was working on her final at the same time because she's a little cheater. It won't matter, I promise you. All right, that's it for tonight.